Hello, and welcome to this Tungsten Masterclass training session where we take a deeper look at the connector. My name is Chris Parker, VP of Customer Success. So first, in this short course, we're going to explore the Tungsten Connector or Proxy. We're going to look at Bridge Mode versus Proxy Mode, and we'll look at the types of routing and how it works. First, just a bit of a recap. We went through this slide on one of our first sessions where we introduced the components of a cluster. We talk of the connector as an intelligent proxy. It's the part of the cluster that controls and aids your applications to connect to the right node in the cluster based on the configuration, such as directing write queries to the primary node and a read-only query balanced across the replicas. There are many different ways to configure the connector, and we'll discuss these throughout this session. We have routing modes, which are either bridge or proxy mode, and then each mode can be configured in a variety of methods as shown here. The connector is fully cluster aware, meaning that the connectors will know if the primary node has moved and react accordingly without the need for you to reconfigure your applications. We've got quite a few blogs on different ways of configuring the connectors, and we have lots of information in our doc pages, far more than we're able to cover in this session, so I do recommend that you review this material as well. Again, we covered this in the command line tools session, but to recap here, there is a command line option called TPM connector. Now, depending on the routing method as to whether this will direct to a primary or a replica. For example, a direct read could connect to a replica in this case. The behavior may differ, and some options are only available if you're running in proxy mode. So if you are in proxy mode, then once connected, you can issue connector help and see a number of options that will display details about the cluster. So for example, you could do TPM connector and then you could issue cluster status to display the current view of the cluster configuration. Before I go into detail on the modes and methods, I first want to talk about QoS or quality of service, as this is a key part of how the various methods work. This setting determines how the connector will behave in each of the modes that you configure. So first we have RW strict. This indicates that the query is a write and will direct you to the primary. And RO relaxed instructs the connector to redirect as if it were a read-only query and will opt for a replica first. If no replica is available or there are other conditions which mean a replica is not viable, then we direct to the primary. The conditions that determine this are highly configurable, and I'm not going to go into detail on all of them in this session. This is explained in our online documentation. The most configurable option here would be regarding latency, and so you can configure the connector in a way that will fail back to the primary node if the latency of a replica is above a certain threshold, thus ensuring you don't read potentially stale data. So most of the routing methods and modes have the QoS set by default, and you should really have to use this or adjust this. However, more advanced users can influence connector behavior by controlling the QoS, and I'll touch on this as we go through the rest of the session. We also have load balancing options, as mentioned here. Most of the time you would never need to adjust this, and each mode and method have the load balancing options set by default. Like QoS, these can be changed and configured to suit your own use cases, but this is also more advanced level configuration, which I'm not going to cover here today. But let's quickly go through these so you can understand their uses. So first we have the default load balancer. This will always route to the primary data source. Then we have most advanced slave. This will look at the node's replication state and the high watermarks and will select a replica that is most up to date. Lowest latency is the default, and as mentioned on the previous slide, this is where the control of ensuring we route to a connector with the lowest latency or replication lag is used. And then round robin, as the name suggests, just loops around all the nodes in a round robin manner. Finally, we have high water slave load balancer, which is the default if you're using SmartScale, and is also mandatory for this routing method. I'll cover SmartScale later in this session, but this is the load balancing rule that allows SmartScale to select the correct node based on the high watermark being equal to or higher. It's a way in which we not only select a most up-to-date replica, but a replica that we know has the data that you are querying for within your session. So let's take a look at the first mode. This is Bridge Mode. This is the default when you install the cluster if you do not select any other mode. Bridge mode is the most simplest and fastest routing method, but at the expense of some of the more advanced features of the connector. Bridge mode acts as a simple router at the network layer, simply connecting your session request directly to the MySQL host. We will route based on other settings, so we can route to the primary or replica if you configure port-based routing, but this routing is not automatic. The connector does not see the queries you are sending and therefore cannot act accordingly. When a connection is made, the connector hands off and has no further awareness. So for that reason, we also cannot seamlessly reconnect should the primary fail over. Therefore, your applications will be disconnected and have to be able to handle this themselves. It's a very fast routing method, but because we're handing your connection off and you have a direct connection to the database, therefore there's no SQL parsing handled by the connector, and the memory overhead for the connector is much lower. This also eliminates the need for the user map for handling authentication, since this is handled directly between your application and the database. As I said, Bridge Mode is enabled by default, but this property can be added to your INI to disable it, or if you want to explicitly have it enabled, more of a visual reference for your users, then you can add it as so. Next, we have Proxy Mode. Proxy Mode is where the connector starts to become more intelligent. Simple Proxy Mode is enabled by just disabling Bridge Mode. This, by default, doesn't automatically enable the read-write splitting though. So what you would then do is configure the behavior of Proxy Mode by choosing the desired routing method as shown here, and we'll cover each of these over the next few slides. Proxy Mode can handle reconnects. There are a few caveats to that, but in its simplest form, if your session is idle, then the connector will automatically reconnect your client in the event of a switch or failover. If your session is in the middle of a transaction, then during a failover the session will be terminated and will need to be reconnected by your application. However, if your session is busy and a switch is issued, then providing the in-flight transaction completes and commits before a predefined timeout period, then the reconnect will happen. User authentication for Proxy Mode is handled by the user.map file, which we'll talk about as we go through each of the routing methods. The way this works is that the connector is actually connected to the database as the application user. Your client connection to the database is via the connector and handled by the connector. The connector then uses the credentials you supply when you connect and authenticates against the user map and subsequently the database. So any new user you create in MySQL, you will also need to be defined along with its password in the user map file so that the connector can then authenticate on your behalf when your client connects. Proxy Mode does consume more memory for the connector, and the more complex the configuration, then the greater this can be. And because of the way in which the connector needs to make decisions on the routing, Proxy Mode can also be slightly slower than Bridge Mode. We can also configure the connectors in what we call mixed mode or fallback Bridge Mode. This combines Bridge Mode and Proxy Mode together, ensuring that you will always have some way of your clients connecting to the database. With this disabled, if you have configured your connectors to run in Proxy Mode and then you create a new database user but forget to define it in the user map, the connectors will fail, your applications will get an authentication failure and you won't be able to connect to the database. With fallback Bridge Mode enabled, if this happens, then the connector will instead connect the client that we cannot authenticate using Proxy Mode via Bridge Mode, whereby we pass your connection off directly to MySQL. You would configure the property by specifying the QoS that you want for this situation. So RW strict means always go to the primary and RO relaxed to a replica. Obviously, this comes with a warning that if a connection falls back to Bridge Mode, then that connection will not have the benefits of Proxy Mode and could behave in a way that you may not expect. So it's always good to have a proper procedure in place when creating new users, but this option provides you with a bit of a safety net. Port-based routing is the first routing method we'll look at. This method can be enabled for both Bridge and Proxy modes. In this scenario, you will define the main application port and a subsequent application read-only port. When the connectors have been started, they will be listening on both of these ports, and then any client connecting through the main application port will always be redirected to the primary. Any clients connecting through the read-only port will be redirected to a replica. This is the simplest mode to configure, however it does require that your application is able to distinguish between read-write and read-only connections and intelligently switch the port in your connection strings accordingly. To enable, simply add the read-only port and optionally disable Bridge Mode if you wish to use Proxy Mode as shown here. But remember, for Proxy Mode you will also need to configure the user map. Our next method is host-based routing. This can be used with Bridge Mode and Proxy Mode as well. This works in a similar fashion to port-based routing, but is handled at the host level by configuring your local network port to run with two IP addresses. So one that you will use for read-write connections and one for read-only. You then need to configure the user map with two entries. One that defines the hostname or IP address that you want to read-write by specifying the QoS of RW strict, and the other using the QoS for RO relax, which would then route to the replicas. So then as your applications connect, depending upon which inbound IP address or hostname they connect to, the connector will detect that and then will route according to that inbound IP address / hostname, and then based on the QoS you set. But again, your applications need to be read-write, read-only aware to ensure that connections route to the correct hostname based on the statement the connection is about to execute. To configure, first ensure the connector host network has been configured with multiple IP addresses and host names, then update the user map with the @host option entries. Additionally, disable bridge mode if you wish to use proxy mode, but also ensure you also have those valid credentials in the user map. And those user map entries are needed even if you are sticking to bridge mode in this scenario. SQL Based Routing, this is only available with proxy mode. The reason for this is that SQL Based Routing, the connector needs to be able to see or interrogate the SQL that is being executed, and that is only possible when we're in proxy mode. So how does this work? Well, this is down to the use of inline comments and hints in your SQL, which can then influence the connector to route the statement accordingly. The hints will specifically set the QoS for the statement, as shown here in the example. By using the inline comment shown in the first example, the hint will only apply to that specific statement. By using the second example, all queries following that comment will be routed based on that QoS. So this method's actually really useful if you're developing a brand new system and you have the ability to use all of these features like adding comments within your SQL. It's less likely to be useful for older legacy applications where the number of code changes would be far too great or not even possible at all. SQL based routing does come with a warning. So if you use the hint to force a statement to a replica, it is your application's responsibility to ensure the statement being sent isn't a write. Obviously, you don't want to be doing an insert or an update on a replica. Similarly, if you use the second comment example where you do the comment and then all the statements after it, you must remember to revert the setting when you've finished. Otherwise, you may inadvertently send statements to the wrong routing method. So any writes to a replica obviously could corrupt the data and be lost. So it's really important that you get that right and you don't mess that up. So to enable SQL-based routing, you supply the following settings in the INI file, and then you use the update the user map accordingly. And obviously, additionally, changes need to be made to your application so that they can take advantage of this routing method. Direct read. Again, this method is only available for proxy mode. As again, SQL routing, the connector needs to be able to see the SQL statement being sent. So this is automatic read-write splitting on a per user basis. So we often call this blind read-write splitting, and what I mean by that is the connectors do not check to ensure the query you are sending returns the results you need, which could result in either no results being returned or outdated results if there's replication lag happening. And it's important to understand the routing rules. So a select and show statements, they will always route to a replica, whereas insert, update and delete will always go to a primary. Additionally, if you do a select for update, although it's a select because you have that for update syntax on there, we'll always route that to a primary. Auto commit has to be enabled. If it's not, then direct read won't work. Again, as this is set on a per user basis, controlled by the content of the user map, this means that in your user map, for example, user A could be configured to use direct, but you may configure a different user to use a different method. This could be both a disadvantage if this is not managed properly, or it could be an advantage. It really depends on your use case. As the connector can see the SQL within bounds of a transaction, anything wrapped around a begin transaction statement, they will also always go to the primary, even if that entire transaction is only made up of selects. And to summarize the risks, you could read outdated data. Additionally, a select call to a function that actually writes data would be routed to a replica, and that could obviously cause data drift. So to enable this, simply disable bridge mode, and then you use the @direct directive within the user map. So for example, I spoke previously about how you could have two different users doing different things. You could have @direct user A, so user A would use the @direct directive, and then any user that doesn't have that @direct will then use whatever other configuration you have within the connector. Finally, SmartScale. This is our more complex configuration. It is similar in concept to direct reads, however with a little bit more intelligence. Where direct read could blindly route you to a replica, SmartScale will inspect the statement, routing accordingly based on session awareness to ensure that reads return the correct data within that current session. So writes, they will always go to a primary as you would expect, but there are also a couple of warnings here as well, same as direct. Anything wrapped in a transaction will always go to a primary. Any tools like Hibernate, for example, that wrap everything in a transaction, even groups all your selects into a transaction, you will not get any benefit from using SmartScale. Also, all ephemeral objects, they only exist on primaries. So temporary tables, for example, they do not get replicated. So for example, if you've got a session that creates a temporary table using that specific MySQL syntax, these will be created on the primary, but then not get replicated. So then if a subsequent select comes along, tries to read that table, that could get routed to a replica and fail because that table won't exist. So if you rely on features such as this, then you may need to reconsider if SmartScale will work for you. So the session ID. This is used so that SmartScale can determine how to route the replicas. As we stated earlier, reads are routed to the first replica that has received the last write within that current session. How is that session defined? It's using the following keywords. There's either database, user, connection, or provided in DB name. We'll talk about these on the next slides, but the default, if you want to try this out, would be database. And as you go down that list from database through to DB name, each one becomes a little bit more complex and involved and more fine-grained access. So let's talk about how session IDs work. So first, database. Applications will always see their own writes immediately because they're talking to the same database. So as long as you're working within the boundaries of the same database, then when you read from other databases, you may see lag, but within the bounds of a single database schema, you will always read the correct data. So at user level, if multiple connections share the same user, then they'll get a consistent view of writes made by that user. But if another user makes a change, you may not see that right away. So again, like database within the bounds of a database, regardless of the user is within the bounds of a user. So it could be different databases here, but it's within the confines of a user. Then we go to the connection level. So only writes from that specific connection are guaranteed to be consistent with its reads. Changes from other connections could be outdated. And then we have provided in DB name. So this is where you would specify a unique session ID within the string of your connection string. This allows you to pass that variable session directly. So for example, a PHP application can pass its own session ID, and that means SmartScale can track things even more efficiently, ensuring reads and writes line up properly throughout that session as it goes along. So how do we enable SmartScale? First, we disable Bridge Mode and we enable SmartScale. Additionally, specify the session ID setting that you require. As I mentioned before, if you don't specify session ID, then database becomes the default. You also need to ensure the user map is updated with the correct users. And finally, any database that uses your application will require this replication client privilege. So if you've got a set of users for your specific applications, you'll need to give them this extra grant so that they can then track and see the replication information to be able to find whether their reads have made it to the replicas. Advanced listeners. So this is a new feature that was added in version 7 of Tungsten. It's an advanced feature. It allows you to combine all of the routing methods and modes that we've talked about to create more complex rules based on different listener ports. It kind of takes the concept of port-based routing but expands to combine additional routing methods within that. And this is all defined in the listeners.json file. If that file exists and has settings in it, then it will override any other specific connection settings within your INI file. So if things are not working quite right and you think, well, I've got all this connection information in my INI, just make sure that you haven't set up advanced listeners and not disabled it by removing that file, because they will override. So one example of how you could use advanced listeners is you could set, for example, port 3306 to be bridge mode for read writes, routing to the primary. You could configure 3307 into bridge mode for read-only queries. And then you could add 3308, an additional port, which you could configure to run in SmartScale. So from there, you can then have multiple different applications that use the connectors in different ways in one single configuration. As I said, it is an advanced feature and it should be used with care, as combining routing methods for different use cases as well as providing flexibility. If you misconfigure it, it could cause confusion with your applications. I highly recommend you review the documentation and blog posts that we have that cover advanced listeners. And if you have any further questions or would like to try it out, then please do reach out to us via the usual support channels. So a quick summary. many properties that I haven't even touched on in this session. Simply, if I had, this session would be several hours long. The connectors are highly configurable and very powerful, and one routing method that works for one customer may not be suitable for another. So we strongly advise you to fully test and understand all of the options and use the best that fits your requirements. We're always available to help you make those decisions and help you with your testing and talk to you in more detail about all of the various different options you can configure, so do not be afraid to ask us. I strongly advise review the extensive documentation that we have available on our doc pages. So what have we covered? Well, we've looked at the connector, we've looked at the different methods and modes, so bridge versus proxy, and then all of the different methods in there, so port-based, host-based, SQL-based, SmartScale routing, etc. So I hope you found that useful. As I said, it really covered the surface of the connector. There is a lot more that we can go into, and I would advise reviewing that documentation. But to repeat once again, if you have any questions, would like to know more, then please do get in touch. But for now, thank you for listening to this session, and I will speak to you again soon. Take care. Goodbye.